Rohini College of Engineering and Technology from Department of Civil Engineering. So this is the subject is our final year students for civil engineer 7th semester. The subject title is C8703 Structural Design and Drawing. Michael Devidurai, Assistant Professor. So today we will see our topic is design and underground water tank. So underground tanks. So example, design the closed rectangular water tank with the internal dimensions of 6 meter into 3 meter into 3 meter. So below the ground level. So mentions here. So below the ground level. Below the ground level means underground water tank. Okay. The nature of soil is always dry and its unit weight is 18 kilonewton per meter square. The unit weight of soil is given in our question. So note it there, and angle of repose is 28 degree. So that soil repose is 28 degree. So draw the reinforcement details. So then given data, so they will given in our internal dimension is equal to 3 meter into 3 meter into 6 meter. Then unit weight of soil is 18 kilonewton per meter square. Then angle of repose is 28 degree. Then nature of soil is dry. Then step number 1, design constants. So the tank with the dimensions of 6 meter into 3 meter and 3 meter and 200 mm freeboard. We can assume that freeboard. So 6 meter into 3 meter into 2.8 meter is equal to finding out for capacity of water. Then let assume let use M20 grade concrete and Fe415 steel. So permissible direct tensile stress of concrete sigma CT is equal to 1.2 megapascal or 1.2 Newton per mm square. Then sigma CBT is equal to 1.6 Newton per mm square. So these values are taken from our code book IS 456 2000 page number 55. Then sigma CBC is equal to 7 Newton per mm square. So this sigma CBC based on grade of concrete. So M20 or M25 anything will be given. So it based on that grade of concrete in our page number 71 IS 456 code book. Then modular ratio M is equal to 280 by 3 into sigma CBC. So we know that sigma CBC. So apply that values. You got it the modular ratio M is equal to 13.33. Then permissible tensile stress of steel sigma ST is equal to 150 Newton per mm square. Then depth coefficient N is equal to 1 divided by 1 plus sigma ST divided by M into sigma CBC. Then liberum coefficient is J is equal to 1 minus N by 3 is equal to 0.872. So step number 2 is the design of walls. So we have the two conditions of that. One is the testing condition, the another one is the empty tank condition. First we need to do that the testing condition because of the tank full of water without support of surrounding of soils. So see that only water pressure acting on that wall from inside. So see the diagram, this is a bending moment diagram. So maximum water pressure P is equal to gamma into H. Gamma is 10 and H is the 3. So P is equal to pressure. Pressure means 30 kilonewton per meter square. Then bending moment at water phase. So at water phase means near water phase. So pH square by 15. This is a bending moment formula. P is the pressure value and H is the height of wall. So is equal to 18 kilonewton per meter per meter. Then bending moment at away from water phase is equal to pH square by 33.5. This is a constant formula. So 30 into 3 is equal to height of water. Then 33.2 is equal to 8.8 kilonewton meter for per meter. Then thickness of wall required for avoiding the crack can be determined by one bending moment formula is that M is equal to sigma CBT into 1 by 6 into B the D square. Sigma CBT is known value. Then B also we can assume this 1000 mm or 1 meter. Then D is the size of the tank wall. So we need to find out the thickness of wall is D is equal to 260 mm. So let's provide 300 mm wall thickness. So empty tank condition, already found the testing condition is success. Then empty tank condition, active earth pressure coefficient. So active earth pressure is K is equal to 1 minus sin pi divided by 1 plus sin pi. So our pi is angle of repose is given in our question. So pi is equal to 28 degrees. So apply that values. Then K is equal to 0.361. Then maximum earth pressure P is equal to K into gamma S into H. So point K is the 0.361. Then gamma is equal to unit weight of soil. Then H is the height of the water tank. Then P is equal to pressure is 19.5 kilonewton per meter square. Then bending moment at the base. So we need to find out the bending moment at base. away from the water phase. Then pH square by 15. This is our formula, we know that. So P is the pressure, then H is the height of wall. Then our answer is 11.7 kilonewton meter per meter. Then calculating area of steel. So bending moment at water phase. At water phase means near water phase. This is 18 kilonewton meter. Then bending moment away from water phase means 11.7 kilonewton meter. Then minimum required steel. The ASD is equal to 0.17 percentage of cross section of area. You got the answer 255 mm square on each phase. Then vertical required at near water phase. You know the one formula, m divided by sigma is the J into D. Then we know that moment 18 kilonewton meter, so convert into Newton mm, so 18 into 10 power 6, so sigma st is equal to 150 into 0.874 into 250 is equal to 528 mm square. So provide 12 mm diabar at 200 mm center to center distance for vertical reinforcement on inner face of the tank. So as well as same as the vertical reinforcement away from water phase also. So formula is the same formula, apply the values. We know all the values, so we can get the directly answers for AST. So provide 12 mm diabars at 300 mm center to center distance spacing on outer face of the tank. Then provide 10 mm diabar at 200 mm center to center distances, horizontal bars on both face of the wall. Then step number 3, design of roof slab. So assume thickness of roof slab is 150 mm. So we can assume that thickness of roof slab. Then loading is the self weight of slab is equal to capital D into unit weight of concrete. So capital D is equal to 150 mm. So we convert into mm to meter. So 0.15 meter into 24. 24 is the unit weight of concrete. You got the self weight of slab is 3.8 kilonewton per meter square. Then live load is given in our question 1.5 meter. 1.5 kilonewton per meter square. Then finishing, floor finishing is a 0.15 kilonewton meter square. So the floor finish is not given in our question, so we can assume that 0.15 to 0.5 kilonewton per meter square. Then add the total load, self weight plus live load plus floor finishing. So total load is we got the 5.25 kilonewton per meter square. Then center to center diameters of the slab is, because the clear span, we can know that clear span, so 3.3 into 6.3 meter. Then design of one-way slab, because the slab is based on the one-way slab or two-way slab basis. So the maximum bending moment in the slab is W L square by 8. We know that W is the total load, so 5.25, and 3.3 is the effective span, so 3 square divided by 8. You got the maximum bending moment in slab is 7.146 kilonewton. Then effective depth required, D is equal to root of 7.1465 into 10 power 6 divided by 1.02 and 1000 mm. So D provided is equal to 150 mm is equal to 11 mm is less than 110 mm, hence safe. Then area of steel requirement, AST is equal to same formula, so apply the values, you got the answer is the AST is equal to 495.56 mm square. Then provide 12 mm diabar at 200 mm center to center distance along the both directions. Then step number 4, design of base slab. So it will be base slab, we can maximum assume that all the values. So based on previous steps, the base slab portions will be changed about the previous steps. Then the bending moment at base of wall will be same for the edge of the base slab. Then hence provide 300 mm thickness with 12 mm diabar at 200 mm center to center distance for top, and 12 mm diabar at 300 mm center distance at bottom. So see the reinforcement details. So this is our 4 sides of walls. So 12 mm diabar at 200 mm center to center distance is the inner face of the wall, and outer face is the 12 mm diabar at 300 mm center to center distance, and the long wall direction is the 10 mm diabar at 200 mm center to center distance. So see that this is the cross section of the tank. So inner face is the 10 mm diabar, and outer face is the 12 mm diabar. Then height of the tank is 3 meter. Then base of the slab is thickness 300 mm. Then base of the slab reinforcement providing also main reinforcement 12 mm diabar. Thank you.